The top view capital PQ of a straight line is 70 mm and makes an angle of 60 degrees with XY line. The end capital Q is 10 mm above HP and 30 mm in front of VP. The difference between the distances of capital P and capital Q above HP is 45 mm. Draw the projections, determine its true length and true inclination with HP and VP. So here he says the top view capital PQ of a straight line is 70 mm, makes an angle of 60 degrees with XY line. So here we have the top view, which is 70 mm, is making an angle of 60 degrees with XY line. The NQ is 10 mm above HP. So when you look from the front view, we can see the distance NQ 10 mm above HP. That image will going to be seen in the vertical plane, which is Q dash, and 30 mm in front of VP. So when you look from the top view, we can see the distance 30 mm in front of VP. So that image will going to fall on HP, which will going to be small q. So that is the distance 30 mm. So now here the end Q is 10 mm above HP and 30 mm in front of VP, and then the top view is making an angle of 60 degrees with XY line and with a length of 70 mm. The differences between the distances of capital P and capital Q is 45 mm. So that is the distance from Q to P. So that distance is 45 mm. That is the difference what he is talking about. And so here, that is the difference which we are talking about here. This is 45 mm. So that point will going to be on this line. So this is 45 mm. So when you get this, so he has given the top view line. So once you get the top view line, so you will going to get the locus of Q, locus of P in the top view. And since the difference is given here, so we know the locus of Q in the locus of P in the front view. So once you know that, so as we know the line which is cutting at this particular point, so we have this is the distance which is above HP, which will going to be the distance, and this will going to be the distance in front of VP. So you got this locus point. So once you know the point, once you know the line which is capital Q and capital P, now we need to find out the true length. So to find the true length, so first we will going to take up the top view now. So here with Q as center, by taking the radius of QP, you rotate such that P1 and both Q and P1 will be in front of VP by 30 mm. So this line which will going to be parallel to VP, so when it is projected in the front view, you will going to get that line which will going to be the true length line, which is Q dash and P1 dash. So when you are rotating in space, when you look from the top view, the image will going to be rotated from here to here. So that means QP1 will be parallel to VP. So when you look from the top view, that is projected here. So this will going to be the QP1. So when you are showing it on the projector, orthographic view, you can see that Q with Q as center, taking the radius of QP, you rotate it and make it parallel to VP. So that means QP1 is parallel to the XY line in the front top view. So when it is projected, it will going to cut the locus of P in the front view. So this point will going to become P1 dash. Then join Q dash P1 dash, which will going to be the true length line, and theta will be the inclination with respect to HP. Now similarly, we need to find out the true length in the horizontal plane. When you want to find out the true length in the horizontal plane, again you take this QP and rotate it and make it parallel to HP now. So how Q is above HP by 10 mm, that P2 should also be above HP by 10 mm. So now the line is parallel to HP, that is QP2. So when you look from the top view, we can see that this will going to be the true length line. So when you are rotating in space like this, the image which will going to be, where that image will going to rotate, when you look from the front view, you can see that Q dash P dash is the one which is we are rotating and make it parallel to HP. Once you make it parallel to HP, its corresponding top view will going to be in true length. So that is, this line will be in true length. So similarly, when you are doing it in the orthographic view, with Q dash as center, taking the radius of Q dash P dash, you rotate it, make it parallel to HP. So that means Q dash is above HP by 10 mm and P2 dash is also above HP by 10 mm. So you make this line parallel to HP. Once you make that line parallel to HP, its corresponding top view. So that means when you are projecting this onto the locus of P in the top view, you will going to get this point as P2. Then join QP2. This will going to be the true length, and phi is the inclination which is made by that with respect to VP. So this will be the true inclination. Now this is how we can analyze this in 3 dimension. Now we will going to analyze by step. So here we know that the end Q is above HP and in front of VP. You know this point, and we know the difference of the point both Q and P, which is above HP by 45 mm, and we know the top view line and its inclination. Once you know that, so you will going to get the line which is in space, and when you are rotating and make it parallel to VP, so that's QP1 is the line which is parallel to VP. When you look from the top view, you can see that QP1 is parallel to VP. It is in front of VP by 30 mm. So when it is projected to the front view, so this will going to cut the locus here. So you're going to get that as Q dash P1 dash. So similarly, with Q as center, you know the top view line and you make it parallel to VP. So QP1 is the line which is parallel to VP. So when it is projected onto the locus of P in the front view, so you will going to get this point as P1 dash. Then join Q dash P1 dash. So this will going to be the truant line. So now we need to find out the true length in HP. So again we are considering that QP, which is line in space. So that means when you look from the front view, so this is the line what we have got with respect to the front view. So now you rotate that QP and make it parallel to HP. That means QP2 is the line which is parallel to HP. So when you're looking from the front view, you are going to get Q dash P2 dash is the line which is parallel to HP, and its corresponding top view. When you look from the top view, you will going to get this line which will going to be in true length. So that means when you are projecting that, it will going to be undercuts the locus of P in the top view here. So you will going to get small QP2. So this is the true length line. So when you are doing it in the orthographic view, you know the front view. So with Q dash as center, taking the radius of Q dash P dash, you rotate it and make it parallel to HP. That is 10 mm above HP, and P2 dash is also above HP by 10 mm. And draw a vertical projector from P2 dash to the top view locus of P. You are going to get this point small P2. Then join QP2. This will going to be the true length. Since it is a true length, you will going to mark this as capital Q and capital P. And the inclination made by this with the inclination made by the true length with respect to VP is denoted by phi. So this is how you will be able to analyze this in step by step also. Now we will going to solve the problem by using the first we will going to draw the XY line and mark XY and VP HP. We know that the NQ is 10 mm above HP and 30 mm in front of VP. So from XY line we measure 10 mm and draw a horizontal line, and similarly from XY line we measure 30 mm below XY line and draw a horizontal line, and then consider any point on this line and draw a vertical projector so that it will go into cuts at both at Q dash and small q. So you mark this as Q dash and you mark this as small q. Then we know that the top view of the line makes an angle of 60 degree with XY line making an angle making a distance of 70 mm. So by using the protractor with Q as center with respect to the horizontal line, you measure an angle of 60 degrees and then draw an inclined line. And then by using the compass with Q as center, taking the radius of 70 mm, cut an arc on that 60 degree line so that you will going to get this point as P. Then join QP with a dark line. So this will going to be the top view. So once you get the point P, so now you draw through P, you draw a horizontal dash dot line and you mark this as the locus of P in the top view. Then the difference between the distances of capital P and capital Q above HP is 45 mm. So we have the capital Q here. So you mark this point as capital Q. The difference of distances of capital P is 45 mm above HP. So from here it is 10 mm. And from here again you measure 45 mm. So then 10 plus 45. So at this distance it will going to be 55 mm from the XY line. Or from capital Q you measure the distance of 45 mm and draw a horizontal dash dot line and you mark this as the locus of capital P. So then You know the top view point, which is here, and you know the locus of Q in the front view. So as we know, the distance between the end projectors will going to cut the locus. So with P as through P, you draw a vertical projector with a thin line such that it will going to cut the locus of P in the front view here, and you mark this point as P dash. Then join, draw a dark line between P dash and Q dash, which will going to be the front view. Now we know it is the front view and we know the top view. Now we need to find out the true length in the vertical plane and also true length in the horizontal plane. So to find out the true length in the vertical plane, with Q as center, taking the radius of QP with compass, draw a smooth arc such that QP, it will go to cut the locus of Q in the top view. So you're going to get this point as, mark this point as small p1. And as you know that QP1 is the line which is parallel to XY in the top view, its corresponding front view will going to be in the true length. So from P1, you draw a vertical projector such that it will going to cut the locus of P in the front view. So you mark this point as P1 dash. Then join Q dash P1 dash with little bit thicker than the XY line. So this will go to be the true length line. And then similarly, we need to find out the true length in the horizontal plane. To find the true length on the horizontal plane, you take Q dash P dash now. So with Q dash as center, by taking the radius of Q dash P dash and draw a smooth arc such that it will going to cut the locus of Q in the front view. That is, Q dash is above HP by 10 mm and P2 dash should also be above HP by 10 mm. So now the front view line is parallel. So you mark this point as P2 dash, and from P2 dash you draw a vertical projector so that it will going to cut the locus of Q in the top, locus of P in the top view, and you mark this point as P2. Then join QP2 with little bit thicker than the XY line. So this will going to be the true length line. So now we need to show the dimensions. You mark the dimensions of 10, 30 and 45, then 70, and then the inclination made by the top view, which is 60 degrees. These are all the known dimensions. And to find the true length, so in any one of these QP2 or Q dash P1 dash, you show the true length line and mark true length as the question mark. And then the inclination made with respect, the true inclination made by with respect to HP is marked as theta, and the true inclination made by the line with respect to VP is phi. Then by using the scale, you measure the length from Q dash to P1 dash, which will going to be the true length, which will going to be 83 mm when you are doing it in manual. When you are doing it in computer, it will be 83.22 mm. And by using the protractor with Q dash as center and measure with respect to the horizontal line, the true inclination made by HP, true inclination made by the line with respect to HP, which is theta, which will be 33 degrees when you are doing it in manual. When you are doing it in computer, it will be 32.74. Again with Q as center, by using the protractor, you measure an angle made by the true length with respect to VP, which will going to be phi, and that phi will be 47 degrees when you are doing it in manual. When you are doing it in computer, it will be 46.76. So this is how we will be able to solve the problem in the sketchbook.